So let us recall what we have did into the previous lecture. We were discussing about the previous lecture about the Chebyshev differential equation. The Chebyshev differential equation can be written as 1 minus x square y double dash plus minus x y dash plus p square y equal to 0. About the ordinary point x is equal to 0, we have solved this Chebyshev equation and we get the solution as in the form of c1y1 plus c2y2, where we will have y1 will be 1 plus summation n running from 1 to infinity 2n minus 2 square minus p square 2n minus 4 square minus p square up to so on 2 square minus p square into minus p square upon 2n factorial into x power 2n, and y2 will be x plus summation n running from 1 to infinity 2n minus 1 square minus alpha square. This is 2n minus 2. 2n minus 3 square minus not alpha square, p square. P square up to so on 3 square minus alpha square 1 square minus alpha square upon 2n plus 1 factorial into x power 2n plus 1. So this was the things we have discussed about the Chebyshev differential equation. The solution can be written in this form. And if you have p, which is integer n, then this y1 and y2 are terminate after certain terms. And in that case, this y1 and y2, it's called the Chebyshev polynomials. That also we have discussed in the previous lecture. Secondly, we have discussed the solution of the Chebyshev equation about the point x is equal to 1, which is the regular singular point of the differential equation. And we have calculated a solution of the Chebyshev equation about this x is equal to 1 point. It can be written as y equal to c1 f of p minus p 1 by 2 1 minus x by 2 plus c2 into 1 minus x by 2 whole raised to 1 by 2 f of p plus 1 by 2 minus p plus 1 by 2 3 by 2 1 minus x by 2. And if this p is an integer, that is n, then this polynomial, that is this hypergeometric series, is known as a Chebyshev polynomial because it's truncated after the nth degree, and it is denoted as Tn of x, which is f of n minus n 1 by 2 1 minus x by 2. We have also calculated certain values of this Chebyshev polynomial, that is for t1, t2 and so on. We will also prove later on that the polynomial, Chebyshev polynomial we get from this one, also from the this one for n equal to, for p equal to n, will be the same one that we will going to discuss later on. In this lecture, we are going to discuss some more properties of Chebyshev polynomials. So for that, we will define, so I can say that a polynomial of degree n, which is bounded at x is equal to 1, is said to be Chebyshev's polynomial if this Tn of cos theta will be cos n theta for every theta belongs to R. What is Tn is this. So instead of x, if I replace cos theta, if it is cosine theta we'll have, then this polynomial of degree is there, then it is a Chebyshev polynomial. It's said to be Chebyshev polynomial if this is the situation is there. Now here we will discuss some properties of Chebyshev polynomial. Let's discuss the property of the Chebyshev polynomial. Let us consider Tn of x is equal to cos of n into cos inverse of x if your x is between -1 and 1 and n belongs to n union 0. So we have to prove this. So for the x is between -1 and 1, let x take x is equal to cos theta. For theta is belongs to close interval 0 to pi. So if your x is between -1 and 1, we can able to take this cos's from -1 to, so x will be cos theta and your theta will be between 0 to pi. Then what is the value of theta? You will have it is cos inverse of x. If I apply cos inverse both sides. Now, what is Tn of x? As we have assumed x is equal to cos theta, we'll have Tn of cos theta we have. As we have taken that Tn of cos theta is cos n theta, so that's why this is equal to cos n theta, and the value of theta we have assumed as cos inverse of x. So hence this is equal to cos of n cos inverse of x, and this we need to prove here. Let us take the another property, the second property. Prove that Tn of x, which is a Chebyshev polynomial, is equal to 1 by 2 x plus square root of x raised to n minus 1 whole power n plus x minus square root of x square minus 1 whole power n if your x is between -1 and 1. So here we need to prove this. To prove this, I want to use the De Morgan's theorem. So by De Morgan's theorem, what is De Morgan's theorem? Anyone can tell me? What is a De Morgan's theorem? It's come under the complex analysis.
Cos theta plus I sin theta whole raised to n equals to cosine theta plus I sin theta.
So this cos theta plus
N belongs to Q.
raised to n equal to cos n plus I sin n theta. Here we have n is integer that we are taking. So this is definitely true. And using this, we also say that cos theta minus I sin theta raised to n will be cos n theta minus I sin n theta. This also we can say. Now, if I add these two statements, if I add them, then this quantity will get cancelled out. So we'll have this will gives you cos n theta, actually 2 cos n theta equal to cos theta plus I sin theta raised to n plus cos theta minus I sin theta raised to n we have. So this is the expression we get, and I want to prove this is the things. And your x is between -1 and 1 is given. So let us consider x is equal to cos theta. So therefore, sin square theta will be 1 minus cos square theta, which is gives you 1 minus x square because cos theta is x. So therefore, sin theta will be square root of 1 minus x square. As your y is only possible, positive value is possible because your x is between -1 and 1, as x is between -1 and 1. So therefore, I sin theta will be I under root of 1 minus x square. So that I can write as I square into 1 minus I square, sorry, x square. I can take this -1 inside the square root. What is the value of I square? Is -1. So this is -1 into 1 minus x square. So this we can write as x square minus 1. So the value of I theta, I sin theta is x square root of x square minus 1. So thus, now Tn of x will have, it is Tn of cos theta. As per the argument, it is cos n theta. And in the previously, we have already calculated what is cos n theta. Cos n theta is half of this whole quantity. So therefore, we can have, this is half of cos theta plus I sin theta raised to n plus cos theta minus I sin theta raised to n. And thus, from this quantity, cos theta and sin theta, we have already calculated. Cos theta is x, I sin theta is square root of x square minus 1. So this is 1 by 2 x plus square root of x square minus 1 whole raised to n plus x minus square root of x square minus 1 whole raised to n. So Tn of x, we have proved that if it is this, if your x is between -1 and 1. Let us discuss the third property. prove that Tn of x plus Tn minus 2 of x will be 2x Tn minus 1x if your x is between minus 1 and 1. And this is known as a recurrence relation of Chebyshev polynomial. What is this known as? A recurrence relation of Chebyshev polynomial. So LHS equal to, I'll start with this side, that is Tn of x plus Tn minus 2 of x. Tn of x plus Tn minus 2 of x. I will start with that. We will prove that that is equal to 2x into Tn minus 1. But Tn of x, if I assume that x is equal to cos theta, then this is Tn cos theta plus Tn minus 2 cos theta. But Tn of cos theta we can write as cos n theta, and this is we can write as cos of n minus 2 n theta, because cos Tn of cos theta is cos n theta. So Tn of Tn minus 2 of cos theta is cos n minus 2 theta. Now we'll use the formula of C plus C, that is 2cc. So this is 2 times cos n theta plus n minus 2 theta by 2 into cos n theta minus n minus 2 theta by 2. So this will gives you 2 cos n theta plus n theta minus 2 theta. So this is 2 n theta minus 2 theta upon 2 into cos, here n theta will get cancelled and then minus, so it is 2 theta by 2. So finally we'll have cos of n minus 1 theta into cos theta. But what is the value of cos theta? The value of cos theta is x. And what will be the value of cos k theta? So it is 2 times, for this we will have x, Tn minus 1 cos theta is the things. But cos theta is again x, so this is 2x into Tn minus 1x, which will be your final answer that we need to prove here. So this is the recurrence relation for Chebyshev polynomial. Let's discuss the fourth property. The fourth things we need to calculate or find T0 of x, T1 of x, T2 of x, T3 of x, and T4 of x. Let us try to calculate what is T0, what is T1, what is T2, what is T3, and so on. Actually, T0 and T1 we already calculated earlier, but let us calculate again. So what is Tn of x, which we have calculated, that is f of n minus n 1 by 2 1 minus x by 2. This is your Tn of x, which we already have earlier. A Chebyshev polynomial is. So what is this T0 of x? And if you use the definition of this hypergeometric series, then this will be 1 plus summation n running from 1 to infinity n into n plus 1 up to n minus n plus 1 into minus n plus 1 up to so on minus n plus 1 into c, that is 1 by 2, or it is, I can say, n factorial, that is 1 by 2, 1 by 2 plus 1 up to so on 1 by 2 minus n plus 1. It is plus n minus 1. This is the thing, plus n minus 1, plus n minus 1 into x power, or instead of x we have 1 minus x by 2 power n. So let us calculate what is T0 of x. T0 of x is f of 0, 0, 1 by 2, 1 minus x by 2. So as per this, if n is 0 and this n is starting from 1, so it is 1. T1 of x, which is f of 1 minus 1, 1 by 2, 1 minus x by 2. So as per this, it will have only two terms. The first term is 1, that is this. When I put n equal to 1, we'll have this term, that is 1. Here it is minus 1 upon 1 factorial into 1 by 2 into x 1 minus x by 2 raised to 1. The next term will become 0 because your minus n plus 1 is there. So that's why it is 0. This quantity will become 0. And if you simplify this will gives you minus 1 minus 2 into 1 minus x by 2. So this will be 1 minus 1 plus x, and the answer is plus x. So we have calculated this. Now how to calculate T2? Any suggestion for to calculating T2? I don't want to use the definition. Without that, can we use that one? You can see that we have the recurrence relation for that. So let us write that recurrence relation again. We know that Tn of x plus Tn minus 2 of x equal to 2x into Tn minus 1 x. This is the things we have. Now put n equal to what? What do you want? T2 you want. So put n equal to 2 here in 1. We get this is T2x plus T0x is equal to 2x T1x. T0 and T1 value we already have from this. T1 is 1, sorry, T0 is 1 and T1 is x. And we'll substitute that 2 value here. So that will gives you, therefore T2 of x plus 1 is equal to 2x into x. So this will imply T2 of x will be 2x square minus 1. So this is the value of t2 of x. Now to get the value of t3, we have to substitute n equal to 3 into this equation 1. So put n equal to 3 in 1. We get t3 of x plus n equal to 3 you have to substitute, that is t1 of x plus 2 into 3 into t2 of x. So t3 of x is actually will have 6 into t2 of x minus t1. And t2 we have, t1 we have x. So we can substitute, that is 6 into 2x square minus 1 minus t1 is x we have calculated previously. T1 is x. Hence this will be 12x square minus x minus 6 is your t3 of x. And to calculate t4, put n equal to 4 in equation 1. We have t4 of x plus t2 of x plus 2x into t3 of x. So this will give you t4x is equal to 2x into t3 of x minus t2 of x. So 2x into t3. The value of t3 is this 12 sorry, how make a mistake here, na? Oh, this x is here. This is not 3, but this is x because it is 2x. So we will not substitute instead of x. We have to substitute t. This is 2x. So this is not c. This is 2x is here. So this will not be the answer. The answer is 2x into 2x square minus 1 minus x. So finally answer is 4x cube minus 2x minus x. So the answer is 4x cube minus 3x will be the polynomial. So that's why this t3 of x is 4x cube minus 3x minus 2x. So t2 of x is 2x square minus 1. 2x square minus 1. And if you simplify this, this will be 8x raised to 4 minus 6x square minus 2x square plus 1. So finally you will have 8x power 4 minus 8x square plus 1 is the, finally you will have this. Now this was to calculate the value of T0, T1, T2, T3 and T4. And due to this, we can able to write down the 1 is T0 of x. X is T1 of x. X square. The value of x square we can get from here. That is T2 of x plus 1 by 2, which we get from this. So that's why we get this is 1 by 2 T2 of x plus 1. We get the value of x cube from here. That is x cube we can get from this equation. We know that T3 of x, we know it is 4. x cube minus 3x. This will gives you x cube will be 1 by 4 into t3 of x plus 3x. But the value of x we can write down in terms of t. So this is 1 by 4 t3 plus 3 into t1, because the value of x we have t1. And here also we can write down 1 by 2 into t2 plus t0, because the value of 1 we have t0. Similar manner, from this we can able to write down what will be the x power 4. So as we have t4 will be 8x raised to 4 minus 8x square plus 1, which implies 8x raised to 4 equal to t4 plus 8x square minus 1. Now the value of t square, we have this. So it is t4 plus 1 by 2, t2 plus 1 by, sorry, t0 minus 1 is there. The value of 1 is t0. So that's why it is minus t0. And further you simplify this. This is t4 plus 1 by 2 into t2 minus 1 by 2 t0, because it is 1 by 2 minus t by 2. 8, this 8 is left to multiply. So it is actually 8 by 2, 8 by 2 0 minus t0. So what will be the, and this will be plus. So what will be the final answer? X power 4 equal to 1 by 8 inside bracket t4 8 by 2 t2, that is 4 t2 plus 8 by 2 minus 1. So it is 4 minus 1. So it is 3t0. So x raised to value of x raised to 4, it is in this form. Thus, what is the conclusion we can write from this? Can somebody tell me? For any n belongs to a non-negative integer, we can write x power n in terms of Chebyshev polynomial. So in the terms of Chebyshev polynomial, we can write down this is the things. And these are the properties of Chebyshev polynomial. Further, we'll discuss more properties of Chebyshev polynomials. So here we note that very important, if you can write down this x power n as a Chebyshev in terms of Chebyshev polynomial, then any function which is analytic, we know that it is has a power series summation n running from 0 to infinity a n x raised to n about x is equal to 0. Then we can able to express this function in terms of Chebyshev polynomial as we have this is a0 plus a1x plus a2x square and so on. So instead of this x, this constant here, this x square, we can able to write down in terms of this Chebyshev polynomial. That is right now it is known as a T2, T3 and so on. That is a Chebyshev polynomial. So that means the next property is actually the next property says that prove that Tn of x will be summation k running from 0 to box n minus n by 2 in of n square upon 2k factorial into n minus 2k factorial x power n minus 2k into x square minus 1 power k. So the next thing is to express your Chebyshev polynomial in terms of polynomial, or I can say in terms of series. Note that again by De Moivre's theorem, we have cos n theta plus I sin n theta equal to cos n theta plus I sin n theta. If I expand this cos plus I sin theta raised to n using expansion, binomial expansion, this will be nc0 cos raised to n theta, nc1 cos raised to 1 sin theta plus nc2 cos raised to 4, sorry, why 4, 2. Here it is I because it is I sin theta plus nc2 cos square into I sin theta n minus 2 is here, so it is square plus nc3 cos raised to n minus 3, this is cos raised to n minus 1 theta into I sin theta raised to 3 up to so on nc n I sin theta raised to n. And on the other side we have this. Now what is the value of I cos theta, I square sin theta, I cube sin theta and I raised to n sin theta? So I want to find out what are the real and imaginary part of this quantity. So just look at what is the real part of this quantity. So I'm comparing real part of LHS and RHS. what we get is cos n theta equal to nc0 cos raised to n theta. The second term we'll have in the real part is this, because I square will be minus 1 and so on. So this real part only contains the even terms, that is nc2 cos square n minus 2 theta into y2 into sine square theta minus sine comes out, plus the next term was nc4 cos raised to n minus 4 I sine theta raised to 4 d theta. The next term will be of 6 and then 8. But what is, first of all, let us see what is this I power 4 sine theta. So I power 4, we know it is minus 1 into minus 1, which is 1. So that's why this value is minus 1. And the further terms is already there. So the finally we'll have, it is nc0 cos raised to n theta, nc2 cos raised to n minus 2 theta into sine theta plus nc4 cos raised to n minus 4 sine raised to 4 theta and so on. We call it, this is as equation 1. What we have to prove is this quantity. So now as we have the axis between minus 1 and 1, we can assume that cos theta, x is equal to cos theta. So sine theta is 1 up minus 1 minus cos square theta. So this is 1 minus x square is there. So if I do the square both sides, then this is sine square theta equal to 1 minus x square. This is minus sine theta, sorry, minus sine square theta by multiplying minus sign both sides. This is x square minus 1. So therefore sine raised to 4 theta is x square minus 1 square, which is x square minus 4x plus 1. What will be the sine raised to 6 theta with minus? So sine raised to 6 theta is cos raised to 6 theta as in the same manner. This is x square minus 1 is there because this is x square is 1 minus x square. Let us do that. It is 1 minus x square whole raised to 3. So that's why it is 6. And 1 minus x square is minus sine theta. So it is minus sine, or I can say it is this only. Yeah, 1 minus is there. So it is minus sine raised to 6 is this. Now we'll substitute all this value into the 1, that is cos raised to n theta is there, cos raised to n minus 2 theta is there, sine theta is there, cos raised to n minus 4 theta is there, sine raised to 4 theta is there. But all this value we can substitute here. So now LHS equal to Tn of x, which is Tn of cos theta, which will be cos n theta. And the value of cos n theta due to this we have calculated. Let us write down, that is the quantity we have, nc0 cos n theta cos raised to nc0 cos raised to n theta plus nc1 cos raised to n minus 1 theta into I sin theta plus nc2 cos raised to n minus 2 I sin n theta square plus nc3 cos raised to n minus 3 I sin theta raised to 3, and so on. Now we'll substitute the value of x, which we have assumed here. X is cos theta. So this is nc0 will gives you 1, x raised to n. nc1 will gives you n factorial upon nc1 is n. So that we can write down as 2 factorial into n minus, sorry, not 2 factorial, 1 factorial into n minus 1 factorial. So it is start with the not one term is not there, only 2 term is there. So that's why it is, yeah, this term is not there. આ term પણ નથી, fourth term વાળી છે. This is fourth. So all the even term will be there. So this is 2. Here is also 2. Then it is cos theta raised to n minus 2. Cos we have assumed is x. So it is x raised to n minus 2. I sin theta. I sin theta, if sin theta is this, then I sin theta in the previous day also we have proved that that is square root of x square minus 1. If I do the square, then it is square of this. So it is x square minus 1. So this is x square minus 1 square. Now square nahi aave, 1 house, power 1. Plus nc4, that is n factorial upon 4 factorial into n minus 4 factorial. X power n minus 4, that is x power n minus 4. I sin theta's power 4, that we have calculated, that is x raised to sin power 4 theta is x square minus 1 whole square. So that's why we have this is x square minus 1 whole square, up to so on. So if the value of n is an even integer, then this can be written as, so let n will be 2k for k running from 0, 1, 2 up to so on, and it is goes up to n by 2. Then Tn will have into the form of summation k running from 0 to n by 2. This is n factorial upon 2k factorial n minus 2k factorial, that is nc 2k. I can write x power n minus 2k x square minus 1 power k is there. So this is the value of Tn we can have. The next property, it's actually called orthogonal property. So prove that the sequence Tn of x n from 1 to infinity of Chebyshev polynomial is orthogonal on the interval -1 and 1 with respect to the weight wx is equal to 1 over 1 minus square root of x. Or the same statement can be written as if Tn running from 1 to infinity is a sequence of Chebyshev polynomial, then prove that integration minus 1 to 1 Tn of x into Tm of x upon square root of 1 minus x square dx is 0 if m equal to n, pi by 2 if m equal to n is not equal to 0, and pi if m is same as n equal to 0. So what does it mean of two polynomials are orthogonal? The meaning of two polynomials are orthogonal is exactly the same, but here they say that with the weight this. So we have the in general the polynomials Pn of x into Pm of x, if you want to say that they are the orthogonal if their product is 0, if they are same, if this index are the same. If it is non-zero, then it has to be 1. Then it is called orthonormal. If this will be 1, then it is called orthonormal. So this is the definition of actually orthogonal polynomials. And with the weight, here one weight is there, so that weight is applicable on this. So that's why we have to prove this quantity. Both the statements are same. Let us try to prove this. Let us consider that I equal to that integration -1 to 1 Tm of x into Tn of x upon square root of 1 minus x square dx. Let us consider x is equal to cos theta. Assume. So therefore dx will be minus sine theta d theta. When the value of x is -1, theta will be pi, because you can just substitute -1. When what value of x or theta will be -1, so we know it is pi. If x is 1, then theta will be 0. So now this integral I is changed into the variable that is 0 to 1 now, instead of -1 to 1. Tm of cos theta, Tn of cos theta upon square root of 1 minus x square, that is 1 minus cos square, which will be actually sine theta, and into minus sine theta d theta is there, and one can observe that this sine theta will get cancelled, and t n of cos theta, we know it is cos n theta. So due to that, we can write down I equal to 0 to 1 cos m theta cos
Sir,
b theta. Yes,
અહીંયા લિમિટ 0 to pi આવશે ને 0 to pi tm cos theta.
एक मिनट, pi. ના pi to 0 આવશે, not 0.
હા એટલે
Pi,
માઇનસ છે એટલે પછી માઇનસ કરી દઈએ તો 0 pi 0 to pi થઈ જશે.
pi to, this will be 0 to pi. And you multiply and divide by 2. This is cos 2m theta cos n theta d theta. So this is again, you have to use that 2cc formula, that is cos m plus n theta plus cos m minus n theta d theta. Now integration of cos, we know it is sine m plus n theta by 2 by m plus n, and this is cos m minus n theta by m minus n. A limit is 0 to pi. Now when you substitute, yeah, provided if m is not equal to n, otherwise this does not have any meaning. Now we know that the value of sine pi or sine k pi is 0 for any k belongs to z. So due to this, when I substitute pi here, both these values are 0. When I substitute 0 here, all of them is 0. So answer will be 0 if m is not equal to n. Now what will happen if m equal to n? And that is not equal to 0 if I assume. So now this integral I from 0 to pi, that is, we have this, that will be cos square n theta d theta, and that is 0 to pi cos square, we know it is 1 plus cos 2 n theta by 2 using the formula of cos d theta. So this is 1 by 2. If I integrate this, this is theta plus sine 2 n theta by 2n. The integration is from 0 to pi. When I substitute pi or limit, this is pi plus 0. When I substitute 0, minus 0 is there. So the answer is pi by 2 if m is not equal to n not equal to 0, because I want to divide this n here. Now if m equal to n, equal to 0, then this integration I from 0 to pi, so this value of n in that case 0, so it will have 1 here dx. So in that case we have, this is theta 0 to pi, so the answer is pi. So that proves this statement, previous statement, that this integration is 0 if m equal to n. If they are equal and if it is non-zero, it is pi by 2, and m equal to n equal to 0, then it is pi. So these are the properties of Chebyshev polynomials we have discussed in this lecture. There are 6 properties that we have proved here. If you have any questions, you can ask for this.